All right, ladies and gents, 4.5 and 4.6. We're talking about graphing basic sine and cosine curves. This is not the easiest thing in the world, but I'm going to do everything I can, show you steps to simplify the process as much as I can, try to streamline it, so you guys can find a way that works for you to figure all the stuff out that you need to find and then graph the curve. All right, what I first want to bring to your attention is what a sine curve or a cosine curve is representing. If you were graphing something that's at x squared, what's the shape going to be? A parabola, right? It might move up and down. It might move left or right. It might get skinnier. It might get fatter. But your parabola, your graph, could shift up and down. It can shift left and right. It can get skinnier. It can get wider. It can get... All of those transformations are the same exact transformations that you will see in your sine curve. It's just going to look a little different, right? In this black portion of the graph that they have highlighted right here, which I'm going to show you right here, this is your parent function of a sine curve. Everybody see what I'm talking about? You see where and all it does is just repeat itself. It just keeps repeating itself over and over and over again. What this is representing, if you're on the unit circle, which we're talking about sine here, and we're talking about sine at 0, sine at pi over 2, pi, 3 pi over 2. You have an x value and a y value. What is sine? Sine is the y. Everybody agree with me? Sine is the y. So if you look at your unit circle, what is the y value right here at 2 pi or at 0? It's 0, which is right there, correct? So now go up to pi over 2. So at pi over 2, what's your y value? 1. So look, at pi over 2, what's your y value? 1, right? So then you're going to come back down to pi. What is your y value? 0, which is right where that dot is, right? Then you go down here to 3 pi over 2. What is your y value? -1. So all this sine curve is one trip around the unit circle that they put on a flat xy plane. So that what makes, all they did was take the circle and kind of undo it, right? And then just went, because if you connected that back together, if you took this part here and this part here, it would make a circle. That's all that these sine curves are. Now we're going to move them left and right. We're going to move them up and down. But the general idea is that you're going to find your increments. Your general idea is the shape of your curve. We're going to talk about basics of sine and cosine, but I just wanted to show you that. If you look here, this is your cosine curve. It's a little different, kind of the same, but think about this. If you have these 4 points on your unit circle, 0, pi over 2, pi, 3 pi over 2, what is cosine, the x to the y? This is your cosine value, right? So look, guys, at 0, what is the x value? 1, correct? Then at pi over 2, what is your x value? 0. At pi, what is your x value? -1. Does everybody see that? So all you're doing is, this is how we are this is how we're finding our curves, is by corresponding parts on the unit circle. Now again, we're going to shift left and right, up and down, but those shifts are going to do the exact same thing that they did to parabolas and all that. You're just going to have to add, subtract. But the basic shape of your sine and cosine curve are always going to be the same. And I'll talk about two differences in a second here. When we talk about a time period, all right, generally the time period we talk about is 2 pi. Sometimes that'll change, and I'll explain to you how that changes and how you find the change. But generally, your one time period is going to be one full circle, one trip around your unit circle. So here are your basic sine and cosine curves. When you have a sine curve, the basic parent function starts at the origin. But you can remember that sine always, unless there's a shift up and down, always starts at the x-axis. God bless you. Unless it shifts up and down, and then it still starts where the x-axis would be, just up or down from there. Your cosine curve is always going to start at the amplitude. And you guys are like, oh my gosh, now she's throwing different words at us. Amplitude just means range. How high and how low this goes, that's it. But there's going to be a bunch of different parts of things to identify to help you figure out how to graph your curves here. Here are the characteristics of your parent functions. The domain for both of them is always negative infinity, positive infinity. Your range for your parent functions, the highest it goes is positive 1, the lowest goes is negative 1. Your parent function time period is 2 pi, intercepts, all that good stuff. This is all basic to the parent function. Now we're going to do a bunch of things that change this. Move it left, right, up, down, that sort of a thing. Go to this slide first. This is a very important slide. Very important slide. Remember, you don't have to write this down, but remember, we had f of x equals a times x minus h squared plus k. Right? That's our standard form, our vertex form of a parabola. What does a tell me? It's our vertical what? Stretch and shrink, right? What does something inside the parenthesis do? Shifts right or left. Is it what we think or the opposite? Okay. And then what does k do? Moves it where? Up and down. The exact same thing happens here. Exact same thing. The a, that's going to be your vertical stretch and shrink. That's your amplitude. So when I say, guys, what is the a? What's the amplitude? You tell me a is whatever. It's how high or how low the graph will go. B is the number that's in front of x. That's how you find the time period. You take 2 pi and you divide it by whatever that number is, the b term. We're going to refer to this a million times. Your C value is your phase shift. If you have something adding or subtracting inside of the parenthesis, it's going to move it left and right, just like it did before. And then D is your vertical shift, up and down. If it's adding something, then you move the points up. If it's subtracting, you move it down. Now, 3 other things that are super important that I want you guys to always identify. Okay, we're going to find our A, our B, our C, and our D. But before you start graphing, just to keep yourself under control, first period today, I did not do this, and it got a little wonky, so that's why I'm going to make sure that we write all this down. You want to find your starting point. I'm going to call it SP. You want to find your time period. A lot of times it's 2 pi, sometimes it's not. And then you want to find your increments. And what I mean by that, your increments are the space that is between each tick mark. So whatever your increments are, you're going to just add it to your starting point. And that's how you're going to find your tick marks. So on your little cheat sheet, how did I tell you to find the starting point? What's it say? What does it say on your cheat sheet? I have it highlighted for you. C over B, right? C over B. That's going to give you your starting point, where your graph starts. How do you find your time period? What you're breaking up your graph into? It's 2 pi, what does your cheat sheet say? Divided by what? Whatever B is, okay? That'll give you your time period. And then your increments. How do you find the space between each tick mark? You take your time period and divide it by what? Divide it by 4. All right? We're going to identify this for every single graph we do. And the more we do this, easier it'll get. We're going to do 4.6 tomorrow. We're just adding tangent and cotangent. And then Friday in class, we're going to practice a bunch. Monday in class, we're going to practice a bunch. I'll give you your 4.4 quizzes back probably on Friday because I still have some makeups. You'll have a little bit of some stuff from 4.4 on your test, but the majority is going to be graphing because it does take, it's a little time consuming. All right, you guys with me? Go to... All right, let's look at some basic stuff. First of all, this is saying to go from negative pi to 4 pi. We don't have to go over the whole entire thing. But we can look at this, and we can find all of the stuff that we just mentioned. The first thing I would do is I would say, okay, what kind of a function are we talking about? Is this sine or cosine? It's sine. So where does a sine function start? At the axis? At the x-axis or at the amplitude? X-axis. So I'm just going to write x-axis. It just helps me remind myself. Now, this is a very basic graph, so the first parts are going to be pretty easy to do. But let's identify all the pieces. I want to know what A, B, C, D are. Then we're going to find our starting point, our time period, and our increments. You guys get in the habit of finding all of these things. The graphing part's easy. So A is my amplitude. Look at your cheat sheet. Have it right next to you. How high and how low does this graph go? What's the number in front? 2, okay? B is the number in front of the x. What is it? 1, okay? C, that's the number in parentheses that you're adding or subtracting to x. 0. D, that's your vertical shift up and down. What are you adding or subtracting to this function? 0, nothing. Okay, good. Now look at your cheat sheet. How do you find the starting point? C over B. Okay, what's my C value? 0 over my B value is 1. So where is this graph starting? At 0. Perfect. How do you find the time period? You take 2 pi and divide it by what? B. Whoops. Yeah, that's right. So 2 pi divided by 1 is what? 2 pi, okay. And why is that important? Because you have to take the time period and divide it by what to find the increments? Divided by 4. You have to take your time period and divide by 4 to find out how far each tick mark is from each other. So if I take 2 pi and I divide it by 4, I get what? Pi over 2. So what you're going to do is take your starting point and add pi over 2 to it. Then you're going to add pi over 2. Then you're going to add pi over 2. You'll see here when you start at 0 and then you're adding pi over 2 each time, this is super simple. So I'm starting at 0, so my first tick mark is at 0. I always do 5 tick marks. But if I start at 0 and I add pi over 2 to it, what do I get? Pi over 2, okay? So now I add another pi over 2. That gives me 2 pi over 2, which is really pi. Then I go where? What's pi plus pi over 2? 3 pi's over 2. This is just your unit circle. And then what's the last one? 2 pi. Okay, great. Now, let's do our amplitude. What's the highest this graph goes? 2. So if the highest it goes is 2, what do you think the lowest it goes is? -2. Very good. And now remind yourself, where does my sine curve start? At the x-axis or the amplitude? So you're going to start here at the x-axis. It's a positive 2. That means we're going to go which direction, you think? Up. So at pi over 2, you're going to go up to the amplitude. Then you're going to come back down to the x-axis. Then you go down to the amplitude, back to the x-axis. And what do you think? If I asked you to do 5 cycles, what would you keep doing? Same thing. You go up to the amplitude, back to the x-axis, down to the amplitude, and back. And then here is your curve that you just created. It's not as difficult as it appears. Is it a lot of stuff at one time? Absolutely. But it's not as hard as it appears. I promise. All right, let's go. Yes, ma'am. Sorry. All right, what kind of a function are we talking about here? Cosine, all right? How is this different? What's the first thing we could tell ourselves? Where is this graph and this graph going to start? At the what? At the amplitude. Good. It's not going to start at the axis. It's going to start at the amplitude. Now, we're going to go through and find ABC and all that stuff. I'm going to find it for one of them. And then you'll see that everything is basically the same for both of them because there's no shifts anywhere. But for letter A, let's find all the stuff. Let's find A, B, C, D, our starting points, the time period, and the increments. Whoa, that's not even close to how you spell increment. Okay, cheat sheet right next to you so you can keep looking at everything. What is the amplitude? What's the highest and lowest this graph goes? 1/2, perfect. What is the time period? What is the number in front of x? 1. C is your phase shift, left and right. What's being added or subtracted in parentheses? Nothing, good. D is your shift up and down. What's being added or subtracted to the entire function? Nothing. So my starting point, how do I find my starting point again? C over B. So I take my C value, put it over my B value, and I get what? 0. Where is this graph starting? At 0, okay. What's your time period? How do you find that? You take 2 pi divided by our B term. So 2 pi divided by 1 is 2 pi. Why is that important? Because that helps us now find the increments. You take your time period of 2 pi, and you put it into 4 parts. What is 2 pi divided by 4? Pi over 2. So what am I adding to my starting point and everything beyond it? Pi over 2. Now, guys, do you notice that your C, D, B, C, D, starting point, time period, all that is the exact same for your B graph? Right? There's nothing being added or subtracted at the end. There's nothing. So I'm not going to go through the whole thing again with you. But we're gonna plot both of these curves so you can see them. All right, so for both of them, your first tick mark is at 0. So if I take 0 and I add pi over 2 to it, what is it? Right? Now I add another pi over 2 and I get pi. Then I add another pi over 2 and I get 3 pi over 2. Then I add another pi over 2 and I get 4 pi over 2, which is 2 pi. Okay. So now I have the highest that either of these goes is positive 3. And the lowest that either of these will go is negative 3. Now here's the difference between the two. All right, I'm gonna do A in red. Again, this is a cosine. We didn't shift up or down, so where do I start? At the amplitude, which is for A, 1/2, right? So I'm gonna start right here. And the next place I go is the x-axis. And then I go to the lowest amplitude, then I go back to the x-axis. Then I go to the amplitude, then I go where? Back to the x-axis. It just continues. You're always going to go between the amplitude and the x-axis. So now let's graph B. We'll do it in yellow. Where does this, yeah?
I'm confused on how you graph.
You always start at, okay, so we started at the amplitude, right, at 1/2. Then the next tick mark will be the axis. Then the next tick mark is the lowest amplitude. Then the next tick mark is the axis. You always alternate, always alternate between amplitude, x-axis, amplitude, x-axis, same thing. Yeah, pattern repeats. So in my cosine curve, where do I start? What's my amplitude in B? 3. So I'm going to start here at 3. And then I hit what? The x-axis at pi over 2. Then where do I go? Then where do I go? Negative 3. Then I hit the x-axis again. Then where do I go? You just keep alternating between amplitude and x-axis. Amplitude and x-axis. Now, if you notice, these two curves are similar. I start at the amplitude. But notice, guys, 1/2. If you had a parabola that had 1/2 in front of it, don't you agree that would be a vertical compression? It'd smush it down. It makes it wider than the original. If you had a whole number 3 in front of your parabola, it would pull it up, make it skinnier. That's what the yellow one did to our normal sine curve. Or cosine, sorry. Does that make sense? Okay. I promise you, as we practice, it'll get easier. You're like, oh my gosh, now you start with something new. This is not anything major. I mean, it is major, but it's not a major thing for you to worry about. If you have a negative in front, it's going to reflect over the x-axis. So guys, with our cosine curves, right? We had cosine. We start at the amplitude. If the amplitude is positive, we start at positive 3. If the amplitude is negative, where do you think you start? Negative 3. If this was a sine curve, if this said 3 sine whatever, or negative 3 sine x, you start, your sine curve starts at the x-axis, right? And it would go up to positive 3. If your amplitude on your sine is negative, it's just a reflection. That means you start at the x-axis and you go which direction? Down. So think negative is down. If it's a cosine, you start at the down. If it's a sine, you go down. Negative down. It's just a reflection over the x. All right, so I want to do I only have two that I want to do. All right, if you're looking at this graph and it says analyze. Whoops, the 3 went away. Put a 3 under here. All right, it says analyze. You're like, what? Oh my gosh. Okay, this is how you need to attack these problems. You take your time, kind of look at what's going on. The first thing I always do is I say, oh, this is a sine function. So if it shifts up or down, then it's gonna, your points will move, and we'll do some of those on Friday. But your sine generally starts where? At the amplitude or the x-axis? X-axis, okay? Just remind yourself of that. Now let's identify all of this stuff. Let's identify our A, our B, all that good stuff. So A, B, C, D. Before you graph, find all this, and then life is easier, I promise. Okay, A. Remind me again what A is. A is it's the amplitude. It's the number in front. What number is in front? 1/2, okay? Positive or negative? It's positive, so 1/2. B is the number in front of your x. What number is there? What number is in front of x? 1. C is the number in parentheses, guys. Now, this is a little tricky. Same trick that we had with parabolas. This is a shift which way? Right pi over 3. How would you move something to the right pi over 3? You would add it, okay? It's the opposite of what you think, just like it was when we did parabolas. And then what is D? How do you find D again? Whatever you're adding or subtracting to the end, there's nothing there, right? Okay. So this one's going to be a tad bit different. Your starting point. This one's not going to start at 0. Let's figure out where this is going to start. My starting point, how do you find it again? It's C over B. C over B. Well, what's my C value? Pi over 3. And what's my B value? 1. So where is this graph going to start? It's starting at pi over 3. So it's starting at pi over 3. It's not starting at 0. We knew that because there's a shift. So my time period. Time period is, how do we find time period? 2 pi over your B value. Well, what's my B value? What's my B value? 1. So 2 pi. The reason that's important is because we have to find our increments. We have to find what we have to add to our starting point. So I take my 2 pi, I divide it by 4. That's how we find our increments. So what am I adding every time now? Pi over 2, which is what we did before. But it's not going to just be 0, pi over 2, pi, because where are we starting? At pi over 3. So here's my suggestion to you. Let me do this over here. All right, you're going to have an xy. And I know my starting point is right here at pi over 3. So now I'm going to write my other tick marks. Again, I always do 5. Now you have to figure out what your next tick marks are. This is the part that can be a tad bit confusing, but it's really not. How do you find what each next tick mark is? What are you adding? So you're going to come over here and you're going to say, okay, I have pi over 3 plus pi over 2. Do we have to get a common denominator? Yes. What is a common denominator between 3 and 2? 6. If I multiply 3 by 2, I get 6. So what you do to the bottom, you do to the top. If I multiply 2 by 3, I get 6. What you do to the bottom, you do to the top. So my next tick mark, what is the value? 5 pi over 6. Perfect. Now how do you find the next one? You have to add what? You have to take 5 pi over 6, and you're going to add. All right, so we're adding pi over 2, right? So then this becomes a 6. Then this becomes a 3. So I get what? 8 pi over 6. Well, that's not what we really should put. What should we put? 4 pi over 3, because it's simplified. So my next tick mark is 4 pi over 3. How do you find the next one, guys? What are we adding? Pi over 2 again. Common denominator. If I multiply the bottom here by 6, 4 times 2 is 8, right? If I multiply the bottom here by 3, I get 6. So multiply the top, what do I get? 11 pi over 6, okay. One more time. My next tick mark is going to be 11 pi over 6 plus pi over 2. What's my common denominator again? 6. So this becomes 3. So I get 14 pi over 6. But we're not going to leave it like that. What are we going to say? 7 pi over 3. Do you see why the phase shifts left and right are the ones that are annoying? Up and down's not a big deal. You'd find the point, and then if, say, it shifts up 2, then you just take each one of your points and move it up 2 or down 2. That's super easy. It's the left and right that can be a little confusing. So now we have to look back and we say, well, wait, what was our original amplitude? 1/2, right? So the highest it goes is 1/2. The lowest it goes is -1/2. Remind yourself again, where does this graph start? The amplitude or the axis? So I'm going to start right here at my starting point. And it's positive. If it was negative, which direction would I go? Down. Since it's positive, I'm going to go up to the amplitude, then back to the axis. Then down to the amplitude, back to the axis. And it would just continue. And there is your sine curve. It's the same sine curve that you started with the parent function. It just moved to the right. You see your phase shift? A kind of a tedious process, I know, but it's not unbearably difficult, I promise. It takes a minute. All right, let's do the last one and then we're done. First thing I'm going to do is say, ooh, where am I going to start this bad boy? Where am I starting this one? At the x-axis or the amplitude? Amplitude, okay, good. How's this one a little bit different? Is it starting at +3 or -3? -3, good, you see it. All right, let's identify all the stuff. I need A, B, C, D. Our starting point, time period, and our increments. All right, what's my A? Okay. What is my B? What's the number in front of X? What's the number in front of X? 2. Ooh, this is a little different.
Wait, is it A 3 or -3?
It doesn't matter. It's fine.
It doesn't matter? Oh.
What is my C? Where does this thing move? It moves which way? Left, pi/4. How would you tell me mathematically I'm going to shift my graph? Visually, how am I going to shift it? Minus, good, pi/4. Remember, it's the opposite of what we think. And then what's our D? Where are we shifting this up or down? We're not yet. We'll get there, but not right now. So my starting point. Remind yourself, how do you find your starting point? C over B, right? What is my C term? -pi/4 divided by B. What's B? 2, which is the same as 2 over 1, right? You guys agree? How do we divide fractions, guys? Keep, change, flip. So -pi/4. Let me write it differently. -pi/4 times 1/2 equals what? -pi over what? 8. That's where we're starting. Where we want to start. That's important. So now let's talk about our time period. We need to know the time period so we know what to split up and add to our starting point. So my time period. How do you find time period? It's 2 pi divided by B. Well, what's my B term, guys? So 2 pi divided by 2. What's my time period? Just pi. Why is that important? Because you take your time period and you divide it by 4, and that is what you add to your starting point. Are we adding pi/2 this time? No, we're adding what? We're going to add that to this and to every tick mark after. So go ahead and get your graph set up. Now, I'm going to give you a blank graph like that so you guys can give yourself room, you can spread out. But what is very important about where I place -pi/8? It's on the left side. I don't care if you put it here or if you put it here. It just has to be to the left of the y-axis. So I'm going to put a tick mark right here at -pi/8. And then I'm going to find my other ones. How do I find that second tick mark? What am I adding? Pi/4. So down here, guys, -pi/8 plus pi/4. Common denominator? 8, right? So this becomes 2. So what's my next tick mark? Positive pi/8. Good. What am I adding again? What do I find for my next tick mark? Pi over 4? Okay. I know what it is. I'm just saying that so you guys are with me. Common denominator would be 8, right? So what's my next tick mark? 3 pi over 8. Now, some of you are like, can I just know in my head that I'm going to add 2 pi over 8? Absolutely. Absolutely. I'm just showing you very basic so you can see this. I'm going to take now 3 pi over 8, and I'm going to add another pi over 4. But again, pi over 4 is the same as 2 pi over 8, right? So my next tick mark is at 5 pi over 8. To get to the next tick mark, I'm going to take 5 pi over 8 and add another pi over 4, which is the same as 2 pi over 8, which gives me 7 pi over 8. Good. Is this brain busting? No. Is it a little bit of a pain? Yes. It's very tedious. If you skip one of these little steps, you might get yourself super duper confused. But I'm going to go back and I'm going to say, okay, let me reanalyze this. First of all, my amplitude was plus and minus 3. So 3 here, negative 3 here, right? Now, this is a tad different from the ones that we've done. How is it a little different? Because it's negative, right? Cosine starts at the amplitude. So is this going to start at positive 3 or is it going to start at negative 3? It's going to start right here at negative 3. Nope, just kidding. I'm sorry. It's going to start at negative 3, but over here, right? I zoomed out too much. The next point that it hits is on the x-axis. Where? At pi over 2. Doesn't touch the origin. Then the next point it goes to is the top of your amplitude. Then the next point it goes to is back to your x-axis. Then the next point it goes to is down to the amplitude. And it would just continue doing the same thing. And then you would connect in a nice, smooth curve. Now, guys, could I possibly give you like 10 of these on a test? No. Right? So you're not going to have a million questions on your next test, but there's going to be a million parts to it. And every part is dependent upon something else. So it is really important that we practice this. All right, I'm going to upload this. You guys should watch it again tonight to kind of get it all in your brain. I know it's a lot, but if you can just find A, B, C, D, and then your starting point, your time period, your increments, the rest of it's not really that bad. Okay, you guys did good today. Thank you. Yeah.